Introducing Festo's Emotion Butterflies, a stunning achievement in bionic engineering that brings the marvel of nature into the realm of technology. These ultralight, agile flying objects emulate the graceful flight patterns of real butterflies through their sophisticated onboard electronics. Each butterfly is equipped with 2 infrared tags on its wings, tracked by 10 strategically placed infrared cameras. A central master computer processes the position data, orchestrating their collective, synchronized movements. This technology not only showcases precise wing control and lightweight design, but also hints at the future of intelligently networked factories, where such systems could revolutionize monitoring and coordination. Watch as these artificial insects effortlessly blend natural beauty with cutting-edge innovation, heralding a new era for the bionic learning network. Meet Festo's Bionic Opter, a revolutionary marvel in bionic engineering inspired by the dragonfly. This incredibly lightweight, versatile flying device replicates the intricate flight dynamics of its natural counterpart. The Bionic Opter can maneuver in any direction, hover, and even glide without wing movement, thanks to its advanced sensors, actuators, and mechanical components. Despite its complexity, it's effortlessly controlled via a smartphone, making it accessible and intuitive. Recognized by Guinness World Records 2020 as the largest flying robotic insect, the Bionic Opter exemplifies Festo's commitment to bionic learning and harnessing nature's optimization strategies for cutting-edge engineering. Witness the future of flight in this extraordinary blend of biology and technology. Introducing the Festo Bionic Swift, a robotic bird that captures the grace and agility of real avian flight. With a length of 44.5 cm, a wingspan of 68 cm, and weighing just 42 grams, this marvel of lightweight engineering features wings made from flexible, durable foam that imitates bird feathers. During upstrokes, the wing segments spread to allow air to pass through, while during downstrokes, they close to generate thrust. All control components, communication technologies, and wing flapping mechanisms are ingeniously housed within its compact body. Equipped with an indoor GPS system for precise, synchronized flight, the Bionic Swift can autonomously correct its flight path if disrupted by unexpected weather changes. Festo Bionic Flying Fox, an engineering marvel inspired by the largest bat species. Despite its impressive of 228 cm and a body length of 87 cm, this lightweight flyer weighs just 580 grams. Operating primarily autonomously within a designated airspace, it utilizes advanced kinematics with internal and external motion tracking systems seamlessly integrated into its electronics. Its wings, in an elastic membrane of ultra-thin, airtight films and knitted elastane fabric, mimic the natural movement of a bat's hands and arm. This innovative design allows the Bionic Flying Fox to control and fold its wings independently, matching the agility and precision of its natural counterpart. Introducing the Festo Bionic Kangaroo, a groundbreaking robotic model inspired by the unique movement of kangaroos. This innovative robot mimics a kangaroo's ability to increase speed without extra energy consumption by efficiently recovering, storing, and utilizing energy with each hop. Combining pneumatic and electric drives, it features rechargeable lithium polymer batteries, a portable energy supply, and either a small compressor or high-pressure storage device. Operable through gesture control via a specialized wristband, the Bionic Kangaroo showcases how nature can inspire future technologies and concepts. Introducing Festo's Bionic Ants, robotic ants designed to replicate the cooperative behavior of real ants. These autonomous components showcase how networked systems can solve complex problems through communication and coordinated actions. Constructed using innovative techniques, including laser-sintered components and visible conductor structures via the 3D MID process, each bionic ant integrates advanced technologies into a compact form. Their leg actuator technology utilizes piezo components known for precision, speed, energy efficiency, and minimal wear. This cooperative behavior opens up exciting possibilities for future production systems, highlighting how bio-inspired robotics can revolutionize industrial automation. Introducing the Festo Bionic FinWave, an autonomous underwater robot inspired by marine animals like the African knifefish and cuttlefish, which use undulating fin movements for propulsion. This innovative robot features two side fins, entirely molded from silicone, that mimic the fluid wave motions of their natural counterparts. Propelled by two internal servo motors controlling 9 lever arms, the Bionic FinWave can produce a variety of wave patterns for precise and smooth movement, unlike traditional propeller drives. Equipped with wireless connectivity, it can transmit data from its temperature and pressure sensors to a tablet, enabling real-time monitoring. Designed to navigate autonomously through an acrylic glass pipe system, the Bionic FinWave exemplifies advanced marine robotics, blending biological inspiration with cutting-edge technology. Meet the MIT Mini Cheetah, a small yet incredibly agile 4-legged robot, renowned for its dynamic movements and robust design. Weighing just 20 pounds, this remarkable machine can perform gymnast-like maneuvers, including walking upright or upside down, trotting over uneven terrain at twice the speed of an average person, and executing a full 360-degree backflip from a standing position. Its modular design, with each leg powered by 3 identical low-cost electric motors, makes component replacement as easy as assembling Lego pieces. Built to be virtually indestructible, the Mini Cheetah can quickly recover from spills, showcasing its resilience and cutting-edge engineering. Ptoy Bitt Robot Dog, a small yet powerful bionic pet designed to enhance STEM and robotics education. This programmable, open-source robot boasts impressive performance powered by BLE, making it an ideal tool for studying, training, and experimenting with quadrupedal robots. Equipped with various visual sensors and controlled by a specialized Arduino board capable of interpreting both simple and complex hand movements, Bitt offers versatile functionality. It can be managed via a smartphone app and programmed using Python, C++, or block-based coding, opening doors to AI applications, robotics, IoT, and real-world exploration. The kit includes a Li-ion battery pack, a wireless dongle for Wi-Fi, and Bluetooth connectivity, 8 servos for walking and head movement, and more. Dive into the future of robotics with the versatile and educational Ptoy Bitt Robot Dog. Introducing the Ptoy Nibble Robot Cat, a revolutionary robotic feline that combines open-source structure with cutting-edge technology. As the fastest and lightest robotic cat in the world, Nibble offers paralleled programmability, allowing you to control its movements and personality entirely. Driven by an Arduino-compatible microcontroller, it stores instinctive muscle memory for fluid motion. You can enhance Nibble's capabilities by adding an AI chip like the Raspberry Pi for advanced perception and decision-making. Constructed out of wood, Nibble features 11 joints and measures 250 mm in length, 107 mm in width, and 140 mm in height. The package includes a Li-ion battery pack, providing approximately 1 hour of runtime. Festo's Airacuda, a cutting-edge bionic fish designed to revolutionize underwater exploration. Operated by remote control and powered by pneumatics, the Airacuda's operation and structure closely resemble that of real fish. Its fluidic muscle system replicates the fin movements of various fish species, allowing it to gracefully navigate through water. By harnessing the fin effect and fin stroke, the Airacuda achieves remarkable propulsion with just 4 actuators, showcasing unparalleled maneuverability. Equipped with an air bladder for maintaining equilibrium and controlled buoyancy, the Airacuda offers an immersive glimpse into the seamless integration of nature-inspired design and advanced robotics. Festo's AquaJelly, an artificial jellyfish that showcases the marvels of autonomous underwater robotics. With its electric motor unit and intelligent adaptive mechanism, AquaJelly mimics the swarming behavior of real jellyfish. Featuring 8 propeller tentacles, a waterproof body, and a transparent hemisphere, this innovative creation navigates 3-dimensional space with grace. Powered by lithium-ion polymer batteries and controlled by a central unit, AquaJelly communicates with a charging station to ensure uninterrupted operation. By coordinating their strategies, AquaJellies can tackle challenges collectively, serving as a platform for research into collective behavioral patterns and advancing the field of underwater robotics.